I'm going to discuss a particular form of the differential equation where I'm having here the differential equation, the form dy by dx ax plus by plus c over dx plus ey plus f. Now these are not that we can make the substitutions, and these are not the homogeneous, because here c is 2. Having the degree of the polynomial here is 0 and here is 1. So it means if we can reduce this one to homogeneous one. So and then from the homogeneous we can separable. So we having non-homogeneous differential equation. We change it to homogeneous one by certain substitution I will explain, and then we change it to separable one. So in this one we will try to make these two values equal to 0. So when we make the substitution, u is equal to x is equal to u plus h and y equal to u plus k, I can have the equation like this one: ax ah plus b k plus c and dh plus ek plus f equal to 0. We solve this one and we get the value of h and k from here. We find the value of k, h and k, and then we use a transformation here that x is equal to u plus h and y is equal to v plus k. We get dx is equal to du and dy equal to dv. Then after when you substitute this one, the value of u and h and d in this equation, then this value of c and df will be 0 because we have already calculated from here. I will give you the example. I will explain with the help of example how we are going to get this one. This is a basic idea, basic method. Then we will get an equation, and this our equation is homogeneous equation. Now in this homogeneous equation, because here degree is 1, degree is 1, degree is 1, now we can make the change over the transformation, change the variable u is equal to v is equal to ut or u equal to vt, any one of them. Then this becomes a separable form. So when we have the separable form, then we integrate both the sides and we get the result. I will explain you with the help of example. I take this example. We want to solve the differential equation. Dy by dx is x minus y minus 3, x plus y minus 1. This is of the same type, which I have just mentioned the method for that one. Now here I want to make this 3 and 1, 0. We take here, as I mentioned, we take our the value of x is equal to u plus h, and value of y is equal to v plus k. And I substitute here, I get two equations. I will get here the equation as x is equal to, and we can get here dx is equal to du. I get here dv, dy is equal to dv. So when I substitute here, I get here dv over du is equal to u plus h, and get minus v plus k and get minus 3. Now this is when we substitute the value of this as u, and now we are having here the denominator. We substitute the value of u, that is y is x is equal to u plus h, and here we get here the value of y is equal to v plus k and get minus 1. I simplify, I open this one. I'll get here u plus h minus v minus k minus 3 over we having here u plus h plus v plus k minus 1. I just take this u and v together. We get here u plus minus v, u minus v, and we get here plus h minus k minus 3 over we get here u plus v plus h plus k minus 1. So here what we want to do, we want to find the value of h and k in such a way that this value and this value both simultaneously become 0. It means from solving these two, we get the value of h and k that will make them 0. So we get here h minus k minus 3 is equal to 0, and here h plus k minus 1 equal to 0. This is my equation 1, and this is my equation 2. I just add this e1 and e2. We get e1 plus e2. That gives me 2. Here is my h, 2h. This is cancelled. Minus 4 is equal to 0. And that gives me 2h is equal to 4. I get here h is equal to 2. I substitute h here. I get here, this is in equation 1, 2 minus k minus 3 is equal to 0. That gives me minus k minus 1 is equal to 0. I give me minus k is equal to 1, or k is equal to minus 1. So I get the value of h is equal to 2. I get the value of k is equal to 1. So my transformation equation will be x is equal to u plus 2 and my value of y is equal to v minus 1. So I'll get here, when substitute here the value of u and v, and you can take here, we're having the value of h and k. For the value of h and k, this will be 0, value of h and k will be 0. And we get here this is my transformation equation. I get dv by du is equal to, we get here, these two are equal to 0, u plus v, and u, get here this equal to u plus v, and substitute in our equation, and we'll get here this equal to u minus v. We're having here the value of dx and dy, and we have the value of h and k. We just substitute here h and k is transformation in our equation. We'll get here this equation. So this equation is my homogeneous equation. I say it's my homogeneous equation. So we're having this homogeneous form. Now we want to reduce it to the form of the separable variable form. So as I mentioned, we will take here v is equal to ut, and then we can write here this value of dv by du is equal to, derivative respect to u is 1 with t plus derivative of respect to this u dt by du. Now I substitute here in my equation the value of u and v and dv by dt. So I'll get here t plus u dt by du is equal to, we get here u minus v, this is u minus ut, or u plus v, this is u plus vt. We simplify it further. I get here t plus u dt by du. I take u common and cancel it. This here is u. And we're having here 1 minus t, or 1 plus t. U is cancelled. We're taking common and cancelling. Then they take this t to the other side. So I can rewrite this one. While getting here this is equal to u dt over is equal to, we take to the other side, we have 1 minus t, or 1 plus t minus t. We get here u dt over du, and simplify this one, we get here 1 minus t minus t minus t square over 1 plus t. Simplify this one, we get here 1 minus 2t minus t square or 1 plus t. We separate the variable. We can take this to the other side. We get here 1 plus t over 1 minus 2t plus t square is equal to du over u. So we can having this form is separable variable form. That's our achievement. Now we can solve it by integrating both the side. Integral of this one, 1 plus t, 1 minus 1 plus t, 1 minus 2t, and here is minus t square, and into dt, and get here integral du over u. Now if we take here this as z equal to 1 minus 2t minus t square, what's my dz? My dz is equal to minus 2 dt minus 2t dt. I will take minus 2 common, get 1 minus t, 1 plus t into dt. So I multiply here by minus 2 and divide by minus 2. We get here 1 over minus 2 here, and then we get here this equal to minus 2 1 plus t dt over 1 minus 2t minus t square, integral of this one, integral of du upon u. Now we integrate that one, we get here minus 1 by 2, get here ln of 1 minus 2t minus t square, and here is equal to ln of u plus ln of c. We shift this one to the other side. I can write here this equal to du over u plus 1 by 2 integral minus 2 1 plus t dt over 1 minus 2t minus t square is equal to 0. So integrated, we get here ln of u plus 1 by 2 ln of 1 minus 2t minus t square is equal to 1 by 2 ln of c. As I told you, we can write the constant in any form we like. We can c to power e or e to power c, whatever you like, you get C1, C2. Now multiply by 2. I get here ln of u square 2u plus ln of we get here 1 minus 2t plus minus t square is equal to ln of c. We can write this as ln of u square into 1 minus 2t minus t square is equal to ln of c. I get here u square into 1 minus 2t minus t square is equal to constant c. Now we are having the value of u. What is the value of u? My u is equal to, from this equation I can just extract my value of u. My value of u is equal to is x minus 2. What's the value of v? My value of v is v plus 1. And what's my value of t? My value of t is equal to, my t is equal to v over u, and that's equal to, what's my v? V is y plus 1 over x minus 2. What's my u? My u is equal to x minus 2. So get here x minus 2 whole square, and it's 1 minus 2, 1 minus t is 1 minus 2, my t is y plus 1 over x minus 2, and then is my t square. My t square is y plus 1 over x minus 2 whole square is equal to c. This is my general solution. So here I just repeat what we did. We take the equation in the form, this is my standard form, and this non-homogeneous, and this example we are going to take. It becomes homogeneous if we are able to remove this equal to 0 and this equal to 0. To make this equal to 0, we take here the substitution x equal to u plus h and y equal to v plus k. Then du will be equal to dx will be du and dy will be dv. We substitute this equation in this equation form, and then we come to the conclusion that if we are able to make this equal to 0 and this equal to 0, find the value of h and k. We solve these two equations, we get the value of h is equal to 2, value of k is equal to minus 1. So we write our transformation equation. This was our transformation equation, that x is equal to u plus 2 and y is equal to v minus 1. We substitute, we get here this equation. From this equation, we reach to this one. The dy by du is equal to u minus 1 and u plus y, u minus v, u plus v. This is my homogeneous equation. This is my homogeneous equation. Now, we substitute the value of, we change it to separable variable. We take v is equal to u plus t. You can take u is equal to v plus vt. It's same, v is equal to ut or u is equal to vt. We substitute and we solve it, and we'll get here the form. We say this is our separable form. When it's separable form, then nothing is left. We simply integrate, and then we substitute the values back. We get our solution. So again, I would like to see that we're having more problems, more examples in my notes, and my notes are in description in the Google, and you can just download my notes. These are free, and you can just take more examples for you to understand it, and more exercises, practice. Mathematics you can't do without doing practice. You have to solve it, you have to write it. Again, you must know the techniques of integration that will help you. Thank you very much.